Hi and welcome to DCO. If you're new here, my name is David Copete, and what I do is I share with you parametric design scripts using Grasshopper. In this particular video, I'll be sharing with you the steps for creating this pattern, but the cool thing about this is that a lot of the steps that you'll see here will be useful for many other design scripts. So if you want to see how it all plugs in, I'm going over all of the steps, but you could also download this from my website, CopeteDavid.com. There, I have this and many other resources that can help you get started right away and save some time. Also learn a little bit more about parametric design, because you can take the scripts and see how they were plugged in, and therefore being able to do that for your own designs. So if you're excited, let me know in the comments below. If you have any questions, I would love to answer those for you. But with that being said, let's jump right into the tutorial and let me show you how this pattern was made. All right, so the first thing that we'll do for this tutorial is going to be to bring in the base geometry. On this one, I'm going to be using a square grid. Now this is going to be a pattern finding exercise. So here, using the grid, we can change the location, but let's keep it here by default on the XY plane. The size we could change, so let's do that. Let's bring in a slider. We'll bring in a slider of 15. And then use two more sliders, so I'll create a copy here. So I'm tapping Alt to create a new copy, and now we'll be using those as the input. Next, we need to decrease this because maybe it's too much, and actually we could probably use one slider just to keep it simple. Obviously, we could change the X and Y extent, but now that we have this, let's now pick just one of these. So I'll take the cells here and I'll go to deconstruct brep. Then let's just pick one of the faces. So I'll go here to item and list item. And as you can see here, the wire means when it's dashed, it means that it's grafted, which means that these are individual groups on their own. And so what we need to do is flatten the list. This way it only picks the first item, which is index of 0. And we can obviously change that if we want to. So if we brought in a slider of 3, you can see that we can cycle through every item. But let's go here with index of 0. Now let's take that on its own and just deselect everything else. Now what we need to do is deconstruct this into its own elements. So let's once again deconstruct brep. Obviously we could copy this one, but now let's plug that into the input, and notice that now we've deconstructed just this panel into its parts, its faces, edges, and vertices. What I'll do now is pick just one of the vertices. So once again, I'll bring in a list item and pick just one of those vertices, or actually it's going to be one of the edges. So now let's hide the brep. Let's hide the panel. And now using this, we're going to subdivide this into a number. So let's go here to divide curve. We'll bring in 6 here. And so now that we've brought this in, what I want to do is create a vector in which this is going to move. Now, the reason why I need to create my own vector is because technically every side is going to have a different direction. So what I need to do is take this line segment, offset curve, and now it's offsetting this way. I actually want it to be in the opposite way. So we'll go to negative. I'll go here, say 1.5. And this way we can create a vector by getting the midpoint of this and the midpoint of this one. And now I'll create a line segment between this one and this one. So I'll bring in line segment that's defined by the start and end point. So we'll start with this point, end at this other midpoint. So notice that it starts here, ends here. And now we can take these points and move them. So I'll take those points, plug them into the input for the move. Then the line segment is going to act as a vector for the amplitude component. And now I can use this line segment as the input for the vector, this vector as the input for the motion. Notice now that if I go here, let's say 1.5, we can move all of those at once. Now here's the thing that we want to do. We want to have a slider independent for each one of these. So if we have 1, 2, 3, 4, 5, 6, 7, 8, let's change that to 1, 2, 3, 4, 5, 6, 7. Change the divisions to have 1 at the end, 1 after, and then 2 here in the middle. So 5 is fine, but we're going to need to have 1, 2, 3, 4, 5, 6 numbers. Now, at the moment, we only have one slider that does all of them. So we could either create more than one slider, plug it in, and start changing them this way, or there's another component called gene pool. And this lets you bring in more than one number. Now here we're going to have 6. Let's change this. So I'll double click here, make the maximum be 20. Now the gene count, let's just bring in 6. And decimals, 2 is fine. So we have 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Obviously, if we change this number, we're going to have to add more or less. So with that being said, let's take this, plug it into the amplitude, and now let's decrease this number to 0 and the last one to 0. And now these can be these floating points that we can change. Now the reason why we want to do this is because now we can go to our points and connect them using interpolated curve. Now what we can do here is plug those in, and notice now that we have the ability to, so I'm going to just go here to 3, this one to 3, and then change this one. We could keep it symmetrical or change it up. But the reason why we want to do this is because when we do it to one line segment, we could at the same time do it to all of them if we programmed it correctly. So let's keep this here. And now we're going to go to this that we flattened. Let's now go to graphed. Now it's doing it to all of those single sides. And if we graphed this list, it will do it to every side at once. So the cool thing about this is that now that we've done it to one panel, let's hide it and let's go to top view. Also hide all the points. And now we have a pattern created using that single curve that we can change here. So this is an exercise in pattern finding. Why? Because we can change these numbers, and as long as you program things correctly, we can see the changes right away. So one of the things that I came up with that looks pretty neat is when you have, let's say this number be 3. Now, one of the things I don't like about gene pool is that you can't double click here and plug in the exact number of 3. Same with this one. Like if I wanted it to be 3, I have to kind of zoom in and be careful that I don't go past it. With this one, do this. Maybe 3 is too large. Let's go here to 1.5. That's the annoying part. It's kind of hard to get precise. Same thing here. Let's do that one more time. Now let's use 3. Oh, let's go to 4. Go to 4. 1. So this creates a cool pattern in the sense that it has this wave, and so it doesn't look rectangular like it usually is. So here's another thing. You bring it back to 0. Notice that it starts from the rectangle. So the other thing is this is an interpolated curve. We can also use NURBS curve, which doesn't use the points to interpolate through, but it uses them as a reference to create that curve. If we hide this one's going to be a little bit more smooth. We can also expand on the pattern here. I'm going to keep this simple here because I'm going to turn these into surfaces. So what I'll do is I'll go here at the end, take all of those, join them together. So I'll type in join curves. Now notice that they're all dashed, which means that they're all independent objects. So let's flatten the input. And now I'll go here to boundary surfaces. And it'll create a surface at the edge of the entire set of pattern. And we can also subdivide this using surface split. So the surface will be divided where? At the location of these curves. I'll make sure to also flatten the input for the curves, otherwise it's going to do that multiple times. Now we have these as surfaces. And the only thing is that you need to keep the first and last one as 0. Otherwise, it won't work. Why? Because it won't be able to split the surface because it will be open. Now, if you want to see what it looks like before the surface, you could do that. It's just not a typical thing that you would do. Like we can move this one around. We can also move this one around. And so with this pattern, or with this concept, you can create many different patterns by changing the numbers here. But also if you want to program a different set of subdivisions, the more subdivisions we have here, the more complex the geometry is going to get. And also, let's say if we have, see how many subdivisions here. If we have 9, then we're going to have 8. And so here we need to change this to be 8. And these down to 0. Now we have more complexity in the pattern. It gets a little bit harder to keep track of, but notice that just with the simple technique like this, you have unlimited range in terms of being able to move some of the edges and create a different set of pattern. Like this is going to be an object, this is going to be an object, and you can expand the tile. Here, you can also increase the number and the size of this. Here we went to 18, that's maybe too many, so decrease the maximum here to be, maybe 10. That's reasonable. and then the size of the pattern as well. So I'll bring this back to, what was it, 7? And then here, decrease this number to 6. All right, so now here, we'll change this to 6. Bring this down to 0. Now, let's bring that back to where it creates a cool pattern here. I'm going to go over one more step here, which is evaluating what the size of each area is, and therefore being able to color it here parametrically. So let me show you that trick. All right, so at this stage, let's take this. Let's first go to shaded mode. Now what we need to do is those fragments, we need to evaluate the area. So to do that, we'll bring in an area component, and each of those fragments or surfaces is going to have a different area. This is going to be the same as this one, but this one's going to be larger than this one. So we'll be able to tell between those two. Now that we have the area, we need to know the smallest and biggest area. So to do that, we'll deconstruct domain using the area input into deconstruct domain. Now we have the start domain and the end domain. So I'll go here to gradient, bring in a gradient component. Now by default, you might have a different color. We can change the presets to be a different color. Let's say we'll use this one because we can change a lot of the colors in between. So the start as the lower limit, the end as the upper limit. Now the next step is going to be with those numbers, we're going to get the biggest and smallest number. So for that, we'll use bounds. And we'll use the area as the input for the numbers. Now notice that with bounds, we get this biggest and smallest number. And so with that, we need to now extract both the biggest and smallest number. So we'll use deconstruct domain one more time. So deconstruct domain. And now we have the start number for 58, the biggest number as 108, and now we can create the average between the two to get the midpoint or the mid number. So here we have 83, and we'll use that as the input for the parameter. Now notice that it doesn't happen yet because all we've done is we've set the stage for the color. Now we need to use the custom preview and use this as the material and the surfaces as the objects we want to color. So here we'll have number 83, but we know it's between 108 and 58. So let's go here to 1. We'll go to 30 less than 80 less than 150. And we'll use this slider to move it around. And you can see now that we can change the color of the pattern. Also disable the preview on that. And now we can see that we can change the color according to this custom slider. Notice that now when I move this around, it changes the color. Now when it goes past the number here, so this is 108, it'll keep all the colors the same. And if I go too low, well, you can't because I set the bottom as 30. So now here with this one, we can be a little bit more subtle about changing those colors, but you're not just bound to these colors, so you can create your own custom gradient. You can change the presets here. So with this, it lets you pick different areas. Now, you'll see here that as soon as I change, let's say one of these, now we're going to have different colors. And the colors change. Why? Well, because the area is going to be different. Go back to 1 point. Let's say let's go back to 1.5 on this one. Well, kind of hard to be subtle on this one. Especially when you have the script a little bit more developed, it takes a little bit longer and it lags a little bit. So this is why sometimes it will catch me just using a different slider input every time. Because when you use a slider, you can double click and change it. This one, it's a little bit more difficult. This one, 2.5-ish. And this is going to be the one that determines the depth. Or actually, this is going to be 1.5. Keeping it symmetrical, right? Like if this one is 1.5, that's 1.5, and then 2.6. Make this. Points we we need one more. So this is why, let's see, 7, 6, 1, 2, 3, 6. Two, 3, 4, 5, 6. That does 1. So if we need 6, then we'll do 5. Here's the trick for that. If you have 6 divisions, 6 numbers here, and you only have 5 divisions here, to keep it consistent, it's a bit of a weird one, but you do 5, or we'll do a slider of 6, which 5, but it'll be 6 subdivisions. That way we know that we can use that. We'll actually decrease this one. 0.5, 0.5. Now with these, we can play around a little bit. This is going to be really cool for creating tile designs or just being able to see your changes as you make them. Also, keeping it not symmetrical is fine as well. Like if this one is this, all right, something like that. So let's now clean up some of this and just show you how I label these. So this is going to be the pattern size. This is going to be the extent. And I like to group it. This way I know that those are kind of the inputs. And also if I'm going to be turning this into a cluster, which is the simplified version of this with just the inputs and outputs, it just helps me be able to just move those over to the left. So this is going to be, this is not that important, the offset, because that's what creates the vector, but this will be. So pattern division. Gene pool is kind of self-explanatory there. Fragments. And then here, I do like to, instead of using just the fragments of that, use a surface component that's empty and use that to kind of hold all the surfaces. So you can also bake those. Group this. Disable the preview on that. And let's bring back a different set of colors here. See if I think I see this. All right, so that's going to conclude this tutorial. This is more than anything an exercise in pattern finding. This is something that is very useful in terms of like learning how parametric design works. Now, there are different applications that we could use for this, but like I said, I just wanted to show you this because my goal here is to show you different exercises, techniques, so you can get closer to learning parametric design to create your own designs. I'll have this available for free on my website for a limited time, but I also have other resources that can help you get started with Grasshopper right away. So you don't have to, learn it all. You could just download some scripts and see how it all works. So thank you very much for being here. Hopefully you found this one interesting and useful. Let me know if you have any comments and questions in the comments below. Otherwise, I hope to see you on the next video.